So what we're going to do in this video is define and explain the fundamental theorem of arithmetic. And what that is, we're going to write it out just like we did the last theorem. Take it by brush. Let P be an element of the integers, such that P, sorry, that's not the correct such that P is less or greater than 1. Then P is prime. This is basically Q. So if we wanted to, we could say Q. And we could say Q is P is prime. If and only if the numbers that divide P are 1 and P. So if and only if 1 and P divide P. So what does this mean? Okay, so let's count. What are the first 10 integers? It's pretty easy. An integer is, or not integer, I meant prime number. So yes, P is prime. So what is the first prime number? Well that's remember, greater than 1. So if the first prime number is 1, we're not going to consider it. Second prime number is 2. Third prime number is 3. And then 4, you can divide 4 by 2. So the next prime number is 5. You can't divide 5 by any of these. 6 can be divided by 3 and 2. So 6 is not a prime number. 7 can't be made up of a product of any of the previous. That makes it prime. So the next one, 8, no. 9, no. 10, 11. 12, no. 13. 14, 15, 16, 17. 18, 19. Remember, no evens can be prime except for 2, because by definition an even is divisible by 2. So 19, 21, 22, 23, and 24, 25, 26, 27. 27, that's 9 times 3. 9 times 3? That is 27, okay. 28, 29. 29. Let me give a little bit of room here. I'll get rid of this 1. And move everything over. Gotcha. Okay, so these are the first 10 prime numbers. And so the fundamental theorem basically says that every integer greater than 1, so anything to the right of 1 on the number line, that's a solid number, is either prime or a product of primes, and this product is unique, up to the order of primes. I don't know what that last part of the statement means, up to the order of primes. So if you understand it, please comment, and I will update and revise this in the next video, or when I redo these videos later. But so what this says is it's exactly what we did to figure out what these numbers are. We counted up and we said the number is either prime, which is what we're looking for, or it can be made up of one of these, because remember we got to 2 and we said 2 is, or we got to 6 and we said 6 is made up of 2 and 3, and then we got to 27 and we said 27 is made up of 3 and then times 9 of those. So 27 wasn't prime because it was made up of a prime number times something else. So as long as the number cannot be made up of any of these numbers or the numbers after it, then the numbers are prime. And I want to show you, I'll probably do it in the next video, but they have lists on, if you just Google it, you can see 50,000 prime numbers. And when you see it, it's like 10,003. You know, it kind of makes sense that you can't divide that by much. But so anyways, if we wanted to analyze a large number, let's say like 10,525. Okay, we know that this can be divided up into fives, and 5 is a prime number, so we divide the first thing into 5. And now we see that this becomes 2, 1, and 25 becomes 5, so 105. So 2105. We know we can divide this into 5s, and so let's chase this all the way down. So 2,105 divided by 5, that's, let's see, if 200 times 5 makes 1,000, then 400 times 5 makes 2,000, so that's 400, and 100, you need 25 to make 100, so that's 26, so 426. We know we can divide that into 2. We all know that 2 is a prime number, so we know 426 divides into 2, and that becomes 413. Now, I don't know anything that divides 413. Let me check, because I don't spend much time trying to figure things out as much as I do just Googling it. So, just like I would have never guessed, 413 is a factorization of 7 times 59. 7 times 59, and this website confirms that 59 is also a prime number. So here are the prime factorizations that make up this number, 10,525. And the theorem says that if the numbers that we determined here, if this satisfies Q such that you can only divide 5 by 1 and 5, then this is a prime number. So 5 is a prime number. 2 we know is a prime number. 7 is a prime number. But what the theorem suggests here is that you can only divide 59 by 1 and by 59. And those are the only way you're going to get an integer out of that quotient. So that is the fundamental theorem of arithmetic. In the next video, we're going to talk about the greatest common divisor, which I'm sure you can guess, but remember, this class is intended to understand how to communicate science or mathematical ideas. And we're going to practice by talking about very common sense things, but we're also going to build off of those and maybe learn a thing or two. So see you in the next video.